Can you tell me a little bit about the mountain longleaf pine ecosystem here at Berry College?
Sure, yeah. We are in what is called the mountain or montane longleaf pine region or ecosystem. We're up here in Lavender Mountain, actually, within one of our stands that we've been managing for about around 20 years now, 15 to 20 years. These are in the Blue Ridge area, right, the mountain ridge and valley section of the state. And it's a component of the mountain longleaf pine ecosystem that extends throughout northwest Georgia and northeast Alabama. So it's up here in the mountains, and it's associated with very steep, well-drained, generally sandstone or quartzite type soils, right? Generally southwest facing slopes in these areas. And it's otherwise very similar to the coastal plain ecosystem. That is, it's dominated by longleaf pine and historically had a rather frequent fire frequency. So for example, in these areas we think the fire return interval was probably about 3 to 5 years, every 3 to 5 years. That's a little less frequent than the coastal plain areas, but nevertheless sufficient to maintain longleaf pine as a dominant species, as well as to maintain a rather diverse understory dominated by grasses, low shrubs, a diversity of wildflowers, wild herbaceous material, and that sort of thing. One of the differences here is that the longleaf pine areas that we have here at Berry and throughout this region have a much higher hardwood component and also a greater component of other pine species. So you have, for example, the other codominant pine is shortleaf pine. You also still have some loblolly and Virginia pine in these locations. And then you have a diversity of oaks and fire-tolerant hickories to some degree. So sand or pale hickory, blackjack oak, black oak, chestnut oak. So for example, this slope that we're looking at right here is a southwest-facing slope, and you can see it's principally dominated by longleaf on those slopes. But if you go back, the topography here, go back over to the northeast slope over here, that's dominated primarily by hickories and chestnut oak. Chestnut oak is very dominant over in those areas. So partially because of topography and partially because of a lower fire frequency, there's more of a shrubby and hardwood component, as well as a greater dominance of other pine species in comparison, for example, with longleaf pine ecosystems on the coastal plain.
Right now we are in a longleaf pine ecosystem in the Alabama Fall Line Hills. The Fall Line Hills are a physiographic transition zone at the innermost region of the coastal plain, just adjacent to the Appalachian Highlands. So these are marine sediments. In fact, at one point these were old barrier islands, right? And because we're at the innermost region of the coastal plain, this is the oldest region where streams have had the longest amount of time to carve the steep slopes and ridges you can see behind me, okay? So we're next to the Appalachian Highlands, which also have steep slopes and ridges, but that topography was formed by tectonic uplift and then downcutting by streams, and you also have soils derived from igneous and metamorphic rocks. But because of the proximity to the Appalachians in combination with the steep topography here, you can also find Appalachian species like chestnut oak, for example, in unburned sites. So fires are ignited from the ridges and allowed to go out naturally as they reach less flammable areas. And you can have hardwood dominated areas with mountain laurel in the understory, for example. But we are still very much in a coastal plain ecosystem, the East Gulf coastal plain to be exact. So if you take an ecoregion approach towards defining longleaf pine ecosystems, again, we're in the East Gulf coastal plain, which is different than the Piedmont and montane uplands, which is where you would find montane longleaf pine ecosystems.
The forest history for the Alabama Fall Line Hills region is relatively well understood from historical documents. We know that in the 1820s, which is just before widespread European settlement in this region, we had a lower density of trees at wider spacings. In fact, the surveyors moving through the region in the 1820s referred to much of this region as open woods. We also suspect that the mean size of canopy trees was greater than it is now. In terms of the composition, the Alabama Fall Line Hills coincides with what the noted botanist Roland Harper referred to as the central loblolly pine belt and the central longleaf pine belt. And we are in the central longleaf pine belt here. And still, longleaf pine is the dominant species on many of the ridge tops and on the south to west facing slopes in this region.
Certainly the Cherokee that were here could utilize fire. They used it as a tool. And then the Europeans, when they moved in, they may have actually accelerated the use of fire to be more frequently than even prior. But with the advent of the fire suppression campaign, generally starting in around the 1920s and 30s, that all ended, right? It practically ended. And that led to long-term fire suppression, decades and decades of fire suppression in many of these relict old longleaf pine ecosystems. That in turn led to a lot of problems. You lose the diversity of understory. You begin to, completely lose the recruitment of longleaf pine. It is what you have, and you don't have any recruitment in the understory. And then you get a real deep buildup of litter and duff. After long periods of fire suppression, longleaf pine grows roots up into that duff. They produce a lot of litter that falls right at the base of the tree. It doesn't decompose very fast, and over decades of fire suppression, roots will grow up into that. The trees become dependent upon that, and then when a fire does happen, those roots get damaged, the tree gets stressed, loses vigor, and could die several years afterwards. So the trees can look perfectly fine right after the burn, right after a fire, but they subsequently die. So it turns out that long-term fire suppression takes longleaf pine from being a tree that's really resistant to fire and dependent upon fire to one that is actually susceptible to fire. So its long-term fire suppression inevitably leads to the demise of the longleaf pines themselves, as well as this diverse understory that is also a component of the longleaf pine ecosystem.
Well, what you're looking at here has been pretty much restored. We used data from the Georgia land lottery maps to figure out what species we thought belonged here and which ones didn't, and about what the stocking ought to be. And so we actually put a logging crew through here. They did fieldwood logging and removed the species that we wanted to get out. What you're seeing is old growth longleaf pine, and then some younger longleaf pine in the mix that were here from before, blackjack oak, post oak, some sand hickory. Research that we conducted on site that was published in the Georgia Academy of Sciences, we documented, based on dendrochronology, the fire history of this site. And what we found is that in the 20th century, it burned about every 13, 14 years, usually a wildfire, often in the summer. Prior to that, this site actually burned about every year in the winter time, and that was the effect of settlers in this area that were grazing the woods and working turpentine in the area. And that went all the way back to about the 1840s. There's about a 20-year gap where virtually nobody lived here, as best we can tell, following the Trail of Tears when the Native Americans were displaced. And then we actually did get data for about 70 years prior to that that documented how the Creek Nation was burning these woods, and they were burning about every 2 to 3 years, and about half their burning was during the growing season. And so that's what we're trying to do. And what you see here is actually a 2-year rough. We're getting ready to burn it again this winter, maybe this spring if we can pull it off in the spring. And that's really our objective, is to burn this site about every 2 years.
So Nathan, is there a way to use fire alone to restore the community?
I wish there was. We found after burning this site for about 2 decades that very little change had happened. We got a little more grass, we knocked down some of the smaller hardwoods, but the hardwoods that are part of our ecosystem, our longleaf ecosystems all over, are fire tough. They can take fire over and over and over again and are not susceptible. So what you're looking at here was logged. We put a fuel wood crew through it, and they took out the hardwoods that we didn't want here. And a lot of this ground was too steep to log, and frankly, the timber value was so low that the loggers weren't interested in it. And in those areas, we used hack and squirt. We hired a contract crew, and we've done hundreds and hundreds of acres of hack and squirt out here to remove the hardwoods that we don't want. We have to do that to get the fire that we want. Burning hardwood litter with a little pine mixed in, you just don't get the sort of fire intensity that you need to maintain this system, and you never gain any ground. But by removing those hardwoods, you get this lush ground cover, these great grassy fuels that come back every year, and that is a tool in your toolbox to keep the ecosystem on the right track. So we've got crews conducting a prescribed fire today on Squirrel Bluff. That's probably a couple miles away. 240 acres on fire. We're getting ready to plant it in a few weeks. And so this is a site prep burn, and you'll notice it's actually burning really well. And the reason why it's burning really well is because the site prep that we used kept our grasses. And so we did not spray with a broad spectrum herbicide like a glyphosate or a Mazapir. We actually did an aerial application of Garlon Escort, knocked back the blackberries, did a great job on the sweet gum, kept our grasses. We did that actually back in early June. The grasses flushed out, grew beautifully, and we're getting a really nice burn out of it. And that's going to make some great ground for the planters in a couple of weeks.
What sort of techniques, maybe besides fire, do you use in this area to preserve biodiversity?
So obviously fire is the first thing. And that is basically going to start the process of taking care of the fire-sensitive species, fire-sensitive hardwoods. But it may not be fast enough in order to really start to recover the understory so that you get a lot of fine fuels in the ground that can very nicely and evenly carry fire through the system. So what you would like to do is accelerate that process, and that's what we did here. We accelerated the opening of the canopy by treating fire-sensitive hardwoods. These are trees that would fall out with continued prescribed burning over time. We treated those with herbicide in such a way to take those out. We actually did it carefully. We sort of took out about a half a year as we went along with direct injection of herbicide. So you take those particular trees out, you still leave a good component of large hardwoods and fire-tolerant hardwoods. You leave all the longleaf pine, all the other pines. But what you end up doing is you start to really open up the canopy, you start to get that recovery of the understory community, and you start getting a better situation in terms of fuel so that the fires will carry evenly and smoothly through the system. So yeah, hack and squirt herbiciding is a sort of special technique that we used here.
Well, this is one of our control plots in a research project we did about 10 years ago, where we looked at a dozen different herbicide mixtures and their effects on ground cover. We did plots here in Pine Mountain on Squirrel Bluff Wildlife Management Area. We also did it in the Sand Hills of West Central Georgia, and we did it down in the wiregrass country of near Thomasville, Georgia, just to have some replication and try to see how the different herbicides were affecting these different ecosystems. What you're looking at here is our untreated control plot, and so this is what we'd like to keep. This is really nice virgin ground cover. We've actually got old growth mountain longleaf behind us, trees 300 plus years old around us, and this is really what I think a lot of us as land managers are shooting for, is this sort of a look. There's actually about 40 species of ground cover right here. We have a 4 meter by 4 meter plot. We put a pin flag in every place we hit a new species, a new plant species, and worked our way outward. And so you can see pretty tight clustering in the lower right corner, and it gets more dispersed as we work further out. So of those 40 species, we had, we had 9 grass species, 2 different legumes, 10 species that we classified as hard or soft mass, 10 woody species, and 13 species that were good for pollinator species or wildflower plants. Here we are at our second plot in our site prep monitoring. This area was aerially sprayed in 2015 with 48 ounces of chopper. One thing to note right away is that there's a lot fewer flags behind me. This is where we monitored our ground cover and put a new pin flag every time we found a new species. In fact, this has less than half as many plant species as our first stop where we hadn't used any herbicide before in that old growth site. So we have 19 plants, only 4 species of grass remain, 4 legumes, 2 hard or soft mass species, and 7 pollinator species. So we lost more than half of the ground cover in the application of imazapyr, and that's fairly typical. Imazapyr is a very broad spectrum chemical. It's really rough on ground cover. The really significant thing that we lost is we lost our good grasses. At the first stop we had switchgrass, split-beard bluestem, big bluestem, and a lot of little bluestem. Here, and we had broom sedge. Here we're left with just broom sedge. And as anybody who burns knows, broom sedge just isn't nearly as good at fire, at keeping out woody plants like sweet gum, at keeping out the blackberries. And so we've got our one hand tied behind our back in our management here. Another thing to note is that the longleaf survival wasn't great. In spite of using a really heavy-handed approach with a broad spectrum herbicide, we planted 519 trees per acre. The current survival is 346 trees per acre, so we got about 66% survival at year 6 after planting. We can live with it, but it's not great, and especially considering that we sacrificed our ground cover to get it, it's not really a good bargain for us.
So tell us a little bit about the wildlife and how they were affected.
Yeah, so we've actually done a multitude of bird survey plots throughout all these different experimental areas. On the old growth site at our first stop, we had 17 bird species per plot on average, which is pretty good. That's a pretty high species richness. Half of the plots in our old growth treatment area where we didn't use any herbicide, we just did the fuel wood thinning and have been burning, half of those sites had quail on them. Here in the imazapyr area, we had 15 bird species per plot on average, so not really a statistically significant difference. But what was significant was that in all the stops that we did in this imazapyr treatment area, we had no quail. And so we also had no backman sparrows in here. And so, you know, it's not that you never get quail in an area that's been site prepped with imazapyr, but given the alternatives, I think they're over there in the old growth where there's a whole lot more food and better cover, and this is sort of second string or third string as far as they're concerned. They'd really rather not use this. There's really not a lot of good escape cover for them. There's not a lot of food diversity. I'm sure the insect diversity is probably a lot less as well. So this is the third site in our project where we were evaluating the effects of site prep on ground cover and on bird species. And well, this site was sprayed in September of 2016 with 2 ounces of Escort and 48 ounces of Garlon XRT. We did it an aerial application. It was hand planted in December 2016, 605 trees per acre. So it actually was planted a year behind the second plot that we looked at. So the longleaf are a little bit smaller, but they're going to catch up in no time. The current survival on this plot is 554 trees per acre, so about 91% survival. So much better survival here than on the broadcast imazapyr plot. That probably was just year-to-year variation. What we've been seeing where we've done this elsewhere is that the Garlon Escort is giving us comparable survival to broadcasts of imazapyr or to glyphosate. So what do we keep in the way of ground cover? Well, there's a lot of good news here. If you see the flags in front of us, this is our measure of ground cover diversity. We actually had 45 plant species here. That's actually 5 more than the reference side, the untreated control. 12 of them were grass, 4 legume species, 5 hard or soft mass species, and 15 pollinator species. And there's about a 45% overlap between this plot and the old growth untreated control. So about half of the species that are in the untreated control are here as well. So we kept about half of the ground cover, or maybe a little better even. So that's really great news. That had a profound effect on the wildlife habitat. So the bird species here, we had 18 species per plot on average, and every single plot that we sampled out here, about 20 of them, had a bobwhite quail detected during the bird survey. So the quail love this. There's great plant diversity, there's great food diversity, there's great bugging. The cover is excellent. We're getting really good longleaf survival. It's just a win-win. And so this is really our preferred way of doing site prep at this point. The old way of doing things with broad spectrum herbicides, blasting everything, and really being heavy on your competition control, that's the old way of doing things. We found, and many others have found also, that using more selective herbicides we're hitting the same longleaf survival, we're hitting our objectives for longleaf and growth, and then on top of that, we're keeping our plant diversity and we're keeping our wildlife. So I really encourage you, to look into this type of more nuanced approach to doing your longleaf restoration rather than just nuking a site and starting
In this region, there are certainly some sites that, based on soils and topography, we would say are longleaf pine sites that have been converted to loblolly pine. Loblolly pine is a much faster growing species and offers a much shorter return on investment. If well managed, loblolly pine will do well on these sites. Historically, loblolly pine was planted on some of these sites to combat accelerated erosion rates from poor farming practices. If loblolly pine on what we think are really longleaf pine sites is not managed or is poorly managed, by age 50 to 60 years, we typically see a lot of low vigor trees, really low life crown ratios, and really high mortality rates. In this region now, we don't see a lot of conversion from longleaf pine into loblolly pine. A central challenge now is to educate landowners on the many benefits for managing for longleaf pine on appropriate sites. And that's the goal. We really want to make sure that we are managing for the proper species based on site conditions. So we know that historically in this region, longleaf pine would have been dominant on xeric and sub-xeric sites, so ridge tops and south to west facing slopes, while loblolly pine was historically more dominant on more mesic sites where it might co-occur with mesic hardwood species.
What impact do you think urbanization has had on the longleaf pine system?
Well, obviously a component of urbanization is development in general, right? And so obviously conversion of these lands to other uses, whether it be agriculture or housing developments or, farms or whatever, tree farms, whatever it is, that's certainly an aspect of urbanization, because the more people you have, the more you have needs for those land uses, and as a result, that certainly cut into a lot of the mountain longleaf pine ecosystem. But even in areas like this, Berry College, it was essentially almost completely protected from that stuff. You have that long-term fire suppression, and you have to restore using fire. You just cannot do it without fire as a tool. Urbanization influences fire in a couple of different ways. You have smoke management, because there's a safety issue of putting smoke into urban areas or urbanized areas. You need to prevent that, and that limits the weather conditions and other parameters under which you can do it, right? And then second of all, you have the air quality in general. And we are in the Atlanta airshed, and as a result, we're limited in our burning pretty much, except for unusual circumstances, to non-growing season burns. So we can burn from October 1st until May 1st, unless we get special kinds of permits to do it. So that automatically cuts 6 months of the year, and it really limits what are called growing season burns, which can be very important for restoration. So those are the two main things: smoke management and air quality issues that can limit the opportunities that you have to burn and how much you can burn at one time, and that sort of thing. So here, we're generally burning very small parcels. Our largest parcel is maybe about 100 acres. That's the main issue, I think, with urbanization right now, in the here and now. Historically, yes, land conversion had a lot to do with it.
Change can have a variety of impacts on longleaf pine ecosystems. One of the first things that comes to mind is with hotter and drier conditions, that could reduce our opportunities to conduct controlled burns or prescribed fires when it's safe to do so, and low-intensity prescribed fires are critical to maintain desired conditions in longleaf pine ecosystems. Another thing is that catastrophic wind disturbance events like tornadoes and hurricanes are hypothesized to become more frequent here in the southeastern United States. So longleaf pine is actually more water use efficient and wind resistant than a lot of other species. So in the context of these climate scenarios with more frequent droughts and wind disturbance events, longleaf pine can be an increasingly important species. Another question is what to do after a disturbance event. So we have a multi-year study looking at the effects of salvage logging and prescribed fire on recovery after an EF3 tornado, you can see the impact of this tornado behind me. And what we found was that salvage log sites actually hosted the greatest longleaf pine sapling densities, suggesting that it did not inhibit recovery towards longleaf pine dominance. However, we also documented homogenized ground flora assemblages, reduced fruiting abundance, and diversity of macrofungal assemblages. So in terms of these ecosystem components and potentially others like birds and reptiles and insects that also rely on deadwood habitat, then it might be a good idea to restrict salvage logging from some zones to enable ecosystem level resilience.
Broadly speaking, we use one of two approaches to create longleaf pine woodlands on appropriate sites in this region, and it depends on the amount of longleaf pine that's in the stand. If there is sufficient longleaf pine growing stock in the stand, then it may be possible to just rehabilitate that stand towards a longleaf pine woodland. If there's not sufficient longleaf pine growing stock, and sometimes there's none, then we would need to regenerate that stand. The break that we use for what is sufficient longleaf pine growing stock tends to be about 30 square feet of longleaf pine basal area per acre. And stands that are at that level or greater, those would be good candidates for rehabilitation. And in those stands, we would thin the basal area down to 40 to 60 square feet per acre, retaining longleaf pine trees. If there's not enough longleaf pine to hit those targets, then we would preferentially retain some of our fire-tolerant hardwood species so that we have a more contiguous fuel bed and can get the desired effects from our prescribed fires. Sometimes you'll see people that suggest retaining some loblolly pine if that's in the system, and we'll do that here too if that's what we have to work with. But loblolly pine is a really prolific cedar, so if there's an unexpected fire gap of just a year or two, then it's possible that with our prescribed fires we're not getting mortality of the loblolly pine. So we usually have some fire-tolerant hardwoods in our systems, things like turkey oak and blackjack oak and southern red oak and post oak and mockernut hickory that will carry fire pretty well. So we would preferentially retain those to hit our basal area targets of 40 to 60 feet per acre. In those systems, it's also sometimes necessary that we come in and by hand remove small diameter stems, things up to about 5 inches in diameter and less. And then we may also use an herbicide to release some of the grasses and forbs by reducing leaf area of real prolific sprouters, things like the red maples and the sweet gums and things like that. This stand was thinned to 40 to 60 square feet of basal area per acre in 2017. It was burned in 2018. In the summer of 2020, the understory was sprayed using a log skidder with 2 quarts of triclopyr per acre and 25 total gallons per acre. And the stand is scheduled to be burned again in the winter of 2021. On sites where we don't have sufficient longleaf pine growing stock, and usually that threshold's about 30 square feet of longleaf pine basal area per acre, then we would often prescribe a clear cut with reserves. And following the harvest, we would use an herbicide application, both broad spectrum and site-specific herbicides, including glyphosate, imazapyr, and triclopyr. And those would be followed with a prescribed burn. And then during the dormant season, we would outplant containerized seedlings, often on a 6 by 10 foot spacing. That's 726 seedlings per acre. And landowners could follow natural slope contours or use a more regular spacing if that was desired. Without hog problems, we can get about 90% survival of the seedlings, but with hog problems that can drop from 50% down to 0%, where the hogs will root up the seedlings and eat the fleshy roots. The first entry in these longleaf pine plantations usually occurs between ages 20 and 30 years. The intent of the entry is to improve health and resiliency by reducing the basal area from over 100 square feet per acre down to 50 to 70 square feet per acre. And the markers would select dominant trees to retain. So these are just some general silvicultural recommendations for ways that we commonly create and maintain longleaf pine woodlands in the Alabama fall line hills. Clearly, we want to make sure that each treatment is tailored towards the specific management objectives and the site conditions.
Longleaf pine does not grow as fast as other southern yellow pines, but there are incentive programs that can make growing longleaf pine profitable. I mentioned earlier how longleaf pine is more water use efficient and wind resistant than other species, so in terms of future climate change scenarios, longleaf pine might be a good option to grow. In the present, longleaf pine is less susceptible to southern pine beetle, which transmits blue stain fungi. And then of course, if you're interested in other wildlife objectives, for example, there are many threatened and endangered species that rely on longleaf pine ecosystems. The red-cockaded woodpecker, for example, which in the state of Alabama actually has its largest population here in the Fall Line Hills.
Our main interest here at Berry is simply a conservation issue, right? This is a globally threatened ecosystem in general, longleaf pine, and the mountain longleaf pine component is the most threatened of all of that, right? It's hardly any of it left. And so we're interested in conserving the biodiversity that's associated with it, not just the trees, but all these plants and animals are associated with the ecosystem just purely from conservation purposes. Foresters don't like to have the wrong tree on a site, right? There had been a widespread use of particular species of pine, primarily loblolly in this area, although slash pine was even planted on this campus. When you plant those kinds of trees in areas they're not quite adapted to, you end up having problems. One of the principal problems we had here was southern pine beetle. It affects loblolly pine, shortleaf to some degree, Virginia pine to some degree. It really doesn't affect longleaf pine at all. So you sort of have a more stable forest resource if you plant longleaf pine where it belongs, right? And you manage for longleaf pine on sites where it belongs. So the right tree in the right place managed the right way. In many cases, longleaf pine is the choice for foresters. Thank you.